Swayam Prabha. Digital India. Educated India.
So good day and welcome back to class number 4 of the course on Geoenvironmental Engineering. So today we are going to make a little shift. We have discussed in the first 3 lectures introduction and soil waste interaction and impact. Now we are going to come to the second module, which is on design of solid waste disposal facilities. That's more on to do with landfills for solid waste. And the next 10 to 12 lectures are going to be on this subject. So let's look at the topic 1 of this module, and that topic is the generation of solid waste and its disposal. So we will see how solid waste gets generated, what do we do with solid waste, and finally where does it land up, and how do these large heaps of waste look like. So to define waste, waste is a byproduct of human activity which has lack of value or use. That means it has no value or use, and therefore nobody is taking it away to use it for some other purpose. And the term solid waste refers to waste that will not move away from the site where it is deposited, because this question will come to you always: is slurry waste solid waste? Is wet waste solid waste? So the term solid waste refers to waste that is solid, that is simple, including semi-liquid or wet wastes with insufficient moisture or fluid content to be free flowing. So wastes which can flow by themselves then don't come under the terminology of solid waste. So we are dealing with all waste which will stay where it was generated or in a nearby area and does not flow away to the nearest drain or river. Now waste can be classified in various ways, and if you look at environmental engineering books, it can be on the physical state. You may have solid waste, liquid waste, gaseous waste. You may use the original use, mining waste, food waste. I mean, what was the waste derived from? Mining activities or food activities. Or you may want to look at the waste as the material of which it is constituted. You may have paper waste, glass waste, construction debris waste. This is the material which may constitute the waste. Sometimes you will find reference to the properties. I mean, this is combustible waste. It might be easy to burn. Or this is compostable waste. That means it may be easy to do biodegradation of the waste and convert it into a compost. Or this may be recyclable waste. So these are some of the terminologies based on properties. Again, sources. You may have domestic waste coming from a residential area. You may have commercial waste. For example, in Delhi, you have commercial centers, you have markets, you have hotels. So domestic waste, commercial waste, you can have hotel waste, you can have market waste and industrial waste. Finally, we would be looking at the safety level definition. We discussed this a little earlier. Waste may be classified as hazardous and non-hazardous, etc. So for the purpose of this course, we will be looking at waste as per the last definition. Just 3 levels of waste. Hazardous being the higher level, non-hazardous being the middle level, and what is often called inert waste, but what I call construction and demolition waste, or that is the lower level of safety. So we will be looking at 3 levels: inert or construction and demolition waste, non-hazardous and hazardous waste. That's what we will do for the purpose of this course. So quickly I run through some terminologies just so that you are able to align with them. There are more terminologies than this. So just so that you are not confused, there's agriculture waste, which comes from agricultural practices, both livestock as well as crop residues. There's mining waste, I've already done this. There may be the overburden from the mining, there may be the tailings from the mining, or there may be the process waste from the mining. Let me restate this. Mining waste, you dig the soil before you reach the ore, is overburden. You reach the rock which has got 5% of the pure material and 95% of the balanced material, so you crush it and crush it. So what remains after crushing and crushing is a powder. Then you send it to a process. After the process is over, this powder will come out and that will be called tailings. But from the process itself, which may involve adding liquids, adding chemicals, the powder is tailings. The pure metal or whatever is the mineral that you are trying to take out, that would come out, and then you would have some third component which may be in the form of a liquid or otherwise in the form of a sludge, which would be the process waste. So you will have the overburden, the tailings, and the process waste. Energy production waste, colloquially in India we talk about it as ash. There will be many types of ashes, but you'll have fly ash, you'll have bottom ash, and you'll have other types of terminologies, but we look at it as energy production waste. In the US, these are called CCRs, coal combustion residuals. Industrial waste can be of various types, depending on what the industry is producing. Is it pesticides? Is it dyeing? Is it chrome plating? Is it petroleum or oil-based industry? There's a huge variety of waste. Is it pharmaceuticals? So really a very, very wide spectrum of industrial waste. Dredging waste. So if you look at the Najafgarh drain, as waste flows, as liquid waste flows in a drain, the heavier particles tend to settle down at the bottom. So from time to time, we have to clean up the channel so that its carrying capacity is not reduced. So often you will see a drag line or a backhoe cleaning up a drain, and this black sediment at the bottom is lifted up and placed on the side. Now, one tends to think that it is kind of a very inert sediments, but since it is traveling with wastewater, it can entrap some contaminants on it. So in some of the developed countries, dredging waste is not disposed of like inert material, but it is disposed of either as a non-hazardous or a hazardous material. So we should know what we are meaning: organic and mineral waste from dredging operations. Construction and demolition waste we have already discussed. Construction and demolition waste we have already discussed, and it can comprise of brickbats, concrete. Even when you are dismantling a road or digging up a road to relay it, then the asphalting material, the pipes, and the construction debris. Very often the waste which you are handling will be sludge from treatment plants. This may be from sewage treatment plant or effluent treatment plant in industrial areas. So sewage treatment plant waste will be very different from a effluent treatment plant waste. But solids from the various sedimentation tanks, sludge digesters of industrial and domestic wastewater treatment plants is treatment plant waste. Household or residential waste is the waste which comes out from the houses or the residential areas. Bulk of it is food. There is paper and packaging. Also important in it is sweepings. So you get dust. You may have it sweepings from the house, but if you are looking at a residential area, then it will also be the street sweepings. So see, when you clean a road, where does the silt go? Do you put it in the drain? stormwater drain, or does it get collected separately, the leaves? So it may have yard waste, etc. Commercial waste refers to, it's similar to the household waste, but it's produced from offices, shops, restaurants. So that each commercial activity is relatively more intense. So if it is restaurant waste, it will be a particular type of waste. If you have office buildings, a lot of stationery and paper will come out of it. And if you have shops, then you have the type of shops that you have. What kind of shops are you having in a particular area? That is, if it's a fruit and vegetable market, then it's fruit and vegetable waste. But if it's a cloth market, then it is rags and cloth pieces that's coming out, bulk from these commercial areas. Institutional waste, well, there's waste which comes out from the IIT. So what will it comprise of? Because we are a residential campus, bulk of it is residential waste. But we also have the academic area, so what comes out of it is like office waste. But our laboratories, that is the tricky one, because in all the labs we are dealing with chemicals. And though it may seem that it's a very small percentage of the total waste which comes out from IIT Delhi, the fact of the matter is that some of those chemicals, especially the ones which remain inside the bottles after the main work has been done, disposal of these chemicals requires that they be treated as hazardous waste. So an institutional waste will have different characters. Coming out from hospitals, it will be more biomedical waste or hospital waste comprising of all the material which is left over after the various surgical operations and everything else, including all the medicines. So they can be pathological and other wastes. So hospitals, research and educational institutions, and these wastes may have to be treated in a very specific manner. Biomedical waste is a term. Earlier it used to be hospital waste, waste produced during diagnosis and treatment in hospitals, microbiological waste, and animal waste from experiments. So I'd like to introduce you to the term municipal solid waste. We discussed about hazardous waste, and we discussed about non-hazardous waste, and we said municipal solid waste is non-hazardous. But what in itself is municipal solid waste? Municipal solid waste is a very heterogeneous mixture of various kinds of wastes. And depending on how you collect your waste, that heterogeneity may vary on any end of the spectrum. And I'll just explain this to you. This term refers to all the waste collected by a municipality and therefore comprises of waste from different sources. Household waste, kitchen, if you have yard waste means if you have a garden, so you'll have some material coming from the garden. In the city there'll be commercial centers, there'll be institutional centers, there'll be construction and demolition, there are park trimmings, there are street sweepings. So it usually excludes agricultural waste, mining waste, industrial waste, energy production waste and dredging waste. But everything else it includes. And sometimes you see, if you go to some of the older sites, waste disposal sites, if you don't have a separate industrial waste disposal area, where is the industrial waste going to land up? So let's just quickly have a look at this. If you look at a city, that's the boundary of a city. So within the city, bulk of it will be residential area. But let's take like Delhi, the center may be Connaught Place, and at one end there might be an industrial area. So this is commercial area, industrial area, and yes, this is a mix of residential plus various other commercial and institutional areas. So I'm just trying to show you this example that we are saying industrial waste will normally not be what we call municipal solid waste. Now suppose this is a city which doesn't have any coherent waste disposal plan, right? So there is one waste disposal site somewhere which started 30 years ago, and we have a site which is here. So the municipal solid waste will also come here, the industrial waste will also come here, and sometimes even the biomedical waste. It's a big hospital you have, then So in the older dumps, you will find that you will have a mixture of all types of waste. The bulk of it will be residential, because that's the maximum waste which is coming out every day from the households. The others will be small. However, as things have improved with time, and suppose for the same city, you now have 3 areas of disposal. Of course, I am showing this just outside the residential limits, but in many cases these have now been engulfed inside the city limits. But now if I have 3, one, I said we'll do one for hazardous, one for non-hazardous, and one for the more inert type of material, the construction and demolition waste. So, which is going to be the largest? The non-hazardous municipal solid waste, or the industrial waste, or the construction and demolition waste? Non-hazardous municipal solid waste. So let me put the sizes in perspective. So if this is the non-hazardous municipal solid waste, I may have smaller sites. And that's a different issue whether all sites are at one location or at different locations. That we will address later. But what I'm now trying to say is that if you have got industrial waste, it will go to the industrial hazardous waste disposal site. And all your municipal solid waste will go to the non-hazardous waste for municipal solid waste. So the hazardous waste site for industrial waste. And the C&D waste will come here. It of course depends on whether you have a collection mechanism or not. You tell the householder, please keep your waste in 3 bins. You have to set up a collection mechanism. At the moment only one guy comes to collect your waste. And maybe he will also have 3 bins. Then he can collect it. But one bin will fill up every day and the other bin will fill up 1/10. So what will happen? That bin may not go to the site till it's filled up. So there are different mechanisms for getting these. So I just wanted to bring to you the overall perspective about the municipal solid waste or waste from a city. We've already discussed hazardous waste, so we won't discuss this any longer, but this is industrial waste could be hazardous, mining waste could be hazardous, even institutional waste, as I talked, could be hazardous if it comes from some labs. So if I look at the processes, what are we consuming from the environment and what are we giving back to the environment? So you will find that we are consuming energy and we are consuming raw materials. So if I want to make any product, let's take this table, I need raw material and then I need energy for the manufacturing devices. The raw material may be wood, and energy for the saw, I may have a sawing mill, so I will need to have energy. So what we take all the time from the environment is energy and raw materials. And energy comes from burning coal or burning diesel, and nowadays from solar power. But our energy can come from hydroelectric power. So basically energy in the form of electricity and raw materials as the principal constituent of what is going to be utilized. So a product may have raw materials from 15 sources. For example, I don't know, an automobile, a car, it would have inputs from thousands of sources. The metal, the sheet metal for the body, the upholstery, the springs, the steering. So we take energy and raw material and then these are inputs to an industrial plant. So the industrial plant will produce a product, but it will also produce waste. So the solid waste starts to get generated at the industrial plant level. Then the products are actually packed, they are packaged. I can't give you 100% pure product. You want a shampoo, I have to put it in a bottle. I can't. So once I have a product, it goes to the consumer. And that's the city. That's the city. So products are consumed and waste is produced. And this waste, it tends to be disposed of on land. So we consume energy and raw material and we dispose the waste on land. Where is the raw material coming from? Raw material may come from the surface of the earth, from beneath the earth. It can also come from the atmosphere. And an industry may be at one location and the consumer may be at another location. I'm sure if we just look at a beverage like a Coke or Pepsi, then the plant of where the Coke is manufactured is at one location and it's being sold all over the city. So the raw materials will come from the Mother Earth, either on the surface or deep below. The industry which produces the product, let's take for example electricity. Coal comes from deep below. It goes to a thermal power plant. The thermal power plant burns the coal. The ash is deposited adjacent to the power plant. The electricity goes in transmission lines to the consumer. And in the case of electricity, there may be no residual waste. But if there was any other product, for example, if I was manufacturing biscuits, then my biscuits would be in a packet. The consumer would eat the biscuits and the waste would come out. And that is going to be placed on the ground. And if you look at it in plan, a city may be getting products from thousands of industries. So thousands of plants around different geological settings. Somebody is giving you electricity, somebody is giving you cars, somebody is giving you biscuits, someone is giving you beverages. They all come to the city. And when we consume them, we get waste. So when you travel into Delhi at about 10 o'clock in the night or later, then you have to stand at the border or the boundaries of the city and see how many trucks are coming in every day. So what kind of trucks you will get? There will be cars in some trucks which are being taken to the car supplier. You will see a lot of cement coming in. There's a lot of construction going on. You get a lot of food coming in for all of us. So the city keeps on getting. And all these trucks go out empty. They don't take back anything with them. The cement came in a cement bag. Did the truck take the cement bag away? No. So they all tend to leave the packaging material in the city itself. So this table is, okay, let me ask you a question. We've talked about mining, industrial, municipal. Which waste do you think is the maximum in quantity? Which waste, in India for example, what is the waste we are producing maximum? Municipal solid waste seems to be a lot of garbage around all the time, or there are some other kinds of waste, which would be more. So I just now compared municipal with industrial and construction and demolition waste. So municipal is large. But if you look at a national perspective, let's first look at India. These are not absolute values. These are not, today we are producing 1,000 million tons. This is just using this as 1,000 and what's happening in the other countries at a particular point of time. So this is not the annual production. Today I think thermal power plants may be producing 120 million tons of ash. So this is when I use mining as 1,000. So the biggest waste that is coming out is mining. And the second biggest waste that is coming out is the agricultural waste. Agricultural waste may not appear to be such a major visual issue because it is diffused on land in the rural areas. All the plant cuttings and everything is diffused. Whereas cities are concentrations of human beings and therefore the waste is building up and therefore it is very much visible to you. But typically please see that what we think is a huge amount of waste is very small in India in comparison to the mining and agriculture, but the impact is important. And in comparison to 26, industrial waste may be 10% or 15%, and construction and demolition waste may be 30%. But thermal power plants are producing more waste. So, and if you look at the US, again, just see. So, it's an industrialized country. Have a look at this, much larger than this. In UK, again, municipal is more than industrial. India has more population, so how come US and UK are producing more municipal waste? Because they're coming out from residential areas. Well, in an industrialized, the more industrialized the society, one human being will produce more waste. Per capita waste production is much more. So that's why you'll find that this is the kind of situation that you have. Okay, let's go forward. Now, as I told you, the waste can be chemically active, biologically active, or physically active. And let's look at municipal solid waste. Quite clearly, it is chemically active. All your salt in your food is going into the leftover food is going into the dustbin, and sodium chloride is mobile, so it's chemically active. Your food itself is biologically active and physically active. There'll be fines, there's all kind of heterogeneity. So the municipal solid waste exhibits all three properties. Industrial waste is industry specific. So if you're an industry which is mainly dealing with inorganic products, then it will be chemically active but may not be biologically active. And physically active, yes, because it will have the particles which can move away. But if you are in an industry which is having organics and bioproducts, then it will be biologically active. So bulk of the chemical industry does not necessarily produce biologically active waste. My experience with hazardous waste landfills recent years has been that most of the waste which comes in is inorganic hazardous waste. And if there is organic hazardous waste, there is a tendency to burn it in incinerators and only send the ash to the waste site. Energy production waste, like we talked about ash. Ash is definitely biologically not active. It is coming out of the burning of coal. It's physically active. It has fine particles. It creates dust. Suspended particles go into the water. Is it chemically active? This is debatable. So there are some issues about heavy metals coming out from over a long period of time from huge ash dumps. There are both sides of both points of view, that there are heavy metals, but they are beneath or within the limits. But there is another point of view that there are heavy metals and they gradually accumulate with time and are harmful to the environment. The mining waste typically is chemically active and physically active. Not the overburden. The overburden waste may not be, but the tailings and the process waste would be chemically active and physically active. And if you have a municipal solid waste dump, within the dump, when you put all this waste, you have all kinds of reactions taking place, anaerobic and aerobic decomposition in the presence of air, and oxygen in the absence of oxygen. I already talked about dissolution, evaporation, sorption, precipitation. All this will be happening. And physical changes, movement of gases, movement of fine particles, settlement of the waste, these are all occurring in the waste dump. And when we take this waste and put it on land, and we've discussed this waste becomes a part of the hydrological cycle. Rainwater will come to that area and all kinds of associated problems will be there. So I'm going to revisit this journey we had in the beginning in the introductory class, look at some waste dumps and look at the kind of scenarios which exist in the country. We've already looked at this slide. This is a municipal solid waste dump in Delhi. This is a photograph of the municipal solid waste dump in Hyderabad. And this is a photograph of the municipal solid waste, one of the municipal solid waste dumps in Mumbai. So please understand, a huge city like Delhi or Mumbai will not have one disposal site. They may have 2 to 3 or 4 disposal sites, whereas the smaller cities will have one disposal site. Why? If you have a big city like Delhi, what is the size of Delhi? What? I think 40 kilometers or 30 kilometers by 30 kilometers. It's like the width and the length. So what happens is, if you have to travel diagonally from one end and send the waste to the other end, you may have to travel 50 kilometers. So you may have 2-3 dumps, east, west, north, south, which might have developed over the period of time. That's Pune for you, that's Ahmedabad, that's Calcutta, Dhapa, and we've already discussed this. You will find leachate coming out. So if you go to a waste dump, you'll find they all have weighbridges. That means you are always measuring the weight of the truck coming in with the waste and the one which is going out to see how much waste has arrived, and the computerized recording system. And this just shows you the frenzy of activity on a waste dump. These trucks are coming in, these are unloading, this is spreading, this is unloading of a municipal solid waste. These are the dozers which are spreading the waste which has come. And these are people who are doing sorting on the site. These are rack pickers. They have been all kinds of litigations in the court because the non-government organizations don't like human beings doing this. And often the court has said that there should be no rack pickers. But what they do is they remove some of the recyclables from the waste. This is the kind of recyclables. They'll take out wires, metal, whatever has value. And then these rack pickers, you will see, they will be on the waste site, and can you see this? These will all be recycled. So in a sense, rack pickers and the kabadi wala which comes to your house to pick up your newspaper and the other waste, they are all recyclers, human recyclers. The only issue is, are we putting their health at risk while we are allowing this? So the courts don't take kindly to this. They don't want rack pickers to be working on the landfill site. There are accidents, there is heavy earth moving equipment which is moving, and also there are cuts and other kinds of things. So there has been this going back and forth about, if you take them off the landfill, then 10% of the material which they are taking away remains in the landfill. And so our kabadiwala system and the rack picker system is an efficient but not so desirable recycling system. In the hierarchy of things, the kabadiwala is better because he's dealing with waste from your house. But those who are working in the landfills come from the lower strata of society. And not all landfills are like dumps. This is a modern landfill which is coming up in India. You can see there's a liner system. We will discuss this. And you can see the waste is covered with soil, and whatever is exposed is also covered with an impervious cover. So we are also now into this area where all this is taking place. As I said, I showed you these dumps outside the city. And if I look at Calcutta, this is about 3 kilometers. This is the dump site. That's where is Calcutta. So the dump site is away from the city, right? However, if you take a closer view, the dump site is right next to these wetlands. So this is the dump site, and these are the wetlands. So it may not be impacting human beings, but it is impacting the wetlands. If you look at Delhi, this is one of the landfills. This whole area is Delhi. I mean, these small houses. Take a closer view. So here the dump is all within. So what has happened? The cities have grown around the dumps. The dumps were outside the cities, and eventually what we find is that as the city grew, this boundary encapsulated it. So when that has happened, the dumps have come into the landfill. Other than municipal solid waste, we have already discussed, this is ash being deposited, but you can see this is dry ash and there is water here. But in another power plant, you will get ash like this. This is a pond with a sedimentation chamber, the ash, a lot of extra water, as you can see. And this is in Visakhapatnam. Once again, this whole place is like a lake with ash buried. They all have their own implications, which we will see later. But this is the kind of waste that we are dealing with. And there's only one place in India where ash is being deposited in a dry state, and that's a mound nearby Delhi. And this is a conveyor belt. which brings ash. This is not the ash on the conveyor belt. This is the photograph seems to suggest, but this is a boom spreader. So ash comes here, it travels up this, and then it makes conical placement. So this boom spreader was first facing this way, and that is the mound that it created. You can see how the mound has risen over time and attempts to vegetate it, because ash will also fly off a lot and cause environmental pollutions around you. This is a view of a chalk mound, again a dry disposal of chalk, again powder. This is a process fluid coming out from lead zinc tailing process, so it's a slurry. It's been put in a pond. So this is basically going to deposit. It's called the jarosite process fluid, and this will impact the environment. And as I talked to you, there was the issue about tailings dams. In the tailings dam, as you can see here, you have made a dam, and behind that, like a lake, you have created and created a pond. Here the mine tailings have been collected. So we are dealing with all these waste disposal facilities, and these are accumulating at the site. Our aim is to tackle them scientifically. Our aim is to tackle them scientifically so that we do not harm the environment. So all our focus is going to be how to design these facilities so that they do not harm the environment. When you deposit something, you have so many problems. If you look at a municipal solid waste dump, we will discuss these, but from a dump, it's not a single pathway. The source is one, but there are innumerable pathways: bad odor, gas, bird menace, which are hitting the plains, dust, litter, erosion, slope failures, and contaminated surface water, contaminated groundwater. We have to look at solutions from an engineering perspective for these problems, for the waste dumps that become a part of the hydrological cycle. So at this stage, we will stop, and we will continue to see how we tackle this in a scientific and engineered manner. But if you have any questions, and if you would like to have some clarification, I'm open to questions. Purely speaking, the waste that we put on the ground, one attempt can be to make it a part of the bigger system. The other attempt can be to encapsulate the whole thing in a kind of a boundary which does not allow its interaction with the outside ecosystem. So we'll see what methodologies or philosophies that we follow in the subsequent classes. The other issue, of course, is can we have no waste? Can we become a zero waste society?
Yes.
Yes and no. So we'll discuss that in the next lecture. Thank you.